All right. Let's see. Is this working? All right. It is. Let's see. Is this working? Yep. All right. So, hey, welcome. Glad y'all are with us today for a podcast. I'm just kind of doing some screen setup so I can make sure that the live feed is working, as well as just the YouTube channel is working at the same time. So, to kind of show you what's going on, we got a nice little triple screen, or dual screen, triple tabs. I don't know, whatever it is. So before I waste any more of your time, let's get to it because I know some of us are studying right now. Sorry, this is so late. I tried to get it to y'all yesterday, but in the event of moving into a house, that kind of took up the majority of my weekend. So glad we're here. Let's get to it. So I got a screen share. How do I do that again? I think I want to screen share, not the test, but desktop one. Let's screen share that desktop. All right, so it should be a screen share. I'm going to wait and make sure that on the YouTube channel that it does show the screen share. There, it's there. Okay, perfect. So what we're looking at is we're going to spend the first 20, 30 minutes, however long it takes, on law sine, law cosine. From there, we'll go to vectors and go into that. So looking at here, whenever we're doing the law of sine and the law of cosine, oops, whoa, what did I do? Let's click that. Don't save here. Okay. Screen. So if I'm starting with the law sine, law cosine, so with the law of sines here, that means if you're ever given a complete set, and what I mean by a complete set, A, B, C, A, B, C. If you're given where you have a complete set here, that means you're going to start with the law of sine first. And again, that's the sine of A over A kind of stuff. And the special case for law of sines, if you're given a complete set and a side, that means that you have a potential of two triangles. And again, that is only for a complete set and a side. So law of sines, you'll be given a complete set, or you can find a complete set without formulas. For the law of cosine, what that means is you're going to be given your triangle, and when you fill out your nice little chart, you'll notice that on that chart, you will be given maybe two sides and an angle or all sides, but notice there's no complete square sets. And so that'll be using that law of cosine formula. And I just want to apologize if I pause a lot. I'm very tired after a long day of moving, as I know many of you are tired as well. And so law of cosine is essentially no complete set. So that's just a little preface before we begin. And so let's get right into it. Well, number one, first off, whenever we start a triangle problem, I want to fill out my chart here. So I got triangle A, B, C, A, B, and C. And so I'm given 115 degrees for angle A, 35 degrees for angle C, and then 200 for side C. So what I'm trying to do is figure out to solve this triangle completely. So to solve it completely, what we're going to do is first look for side A. Or how do I find side A? Law of sine. So I'll do sine of 115 over A. It's going to be equal to the sine of 35 over 200. We'll then cross multiply to get 200 sine of 115 equal to A sine of 135. Now that I'm kind of checking out the YouTube, I'm not sure some people here If you're here, just like do a nice little comment below, just so I know that y'all are here, as well as if you have any questions, you can type in that chat. So just say something like hi or hello or what's up or I'm bored. VV, glad you're with us. I see you're with us here. So let's keep it going. We cross multiply, and so that's going to leave us with, sorry, I got to get my calculator out, sine of 115. Make sure, don't forget those calculators for tomorrow. That's going to leave us with 189 point, oh, let's just do the shortcut way. Shortcut way is this. Once you've cross multiplied, we want to divide by this sign here. And so when we divide by this sign, we're going to get A equal to 200 sine of 115 over sine of 135. And then that's going to equal us 189, but not 189, 174.3. So for side lengths, for side lengths, we're looking just one decimal place, 173.3. Now we're done solving. Now we got to find the angle and the missing side. Now, this angle is easy to find. All we got to do is 180 minus 115 minus 35. Or you can add those two angles up and then subtract from 180. When you do that, you're going to get 30 degrees as that missing angle. And if 30 degrees is that missing angle, we're going to again do the law of sine to find this last angle. And so to do that, we'll just do sine of 30 over B. And I can use the complete set from A or C. I'm going to use the complete set from C because that was given to me. So in case I messed up in A, this won't come back to bite me in the butt. And so that's going to be B sine of 35. So I'm going to divide both sides by this sine of 35. And that will then give me B equal to 316.02. Everett, sup? Glad you're here with us as well. And so we got problem 1 done. It's in the books. It's in the bag. Let's move on to the next one. For this next one here, again, when you're looking at the triangles, you want to start off with notifying what angles you know and what side lengths you know. So I know angle B, I know angle C, and I know side length A. Now, here's the thing for those live streaming. If you know law of sines and law of cosines and you have other things to do, go do those things. Come back in 20 minutes. We'll start vectors then because I don't want to waste your study time. So again, for these first probably 20 minutes, we're going to be solely looking at law of sine and law of cosine. So I want to make sure that you manage your time wisely. So again, we're looking here to determine if it's law of sine, law of cosine. I need a complete set. I don't have a complete set, but an exception to the law of sine is if I can make a complete set without any formulas, then I'm golden. And so with that, I want to be golden. And so to be golden, I'm going to look for this angle here. So that means I'm going to do 180 minus 80 minus 10. And then that's going to give me 90 degrees. This is a good, nice 90-degree triangle. So yes, technically you could use trig, but we're going to, we won't be doing that today. We're going to continue practicing our law of sine skills. And so to practice that, let's look first for side C. Again, for law of sines, the order of where you find your side lengths won't matter. But because in law of cosine, we want to always start with the shortest side first. Let's just get that practice going. And so to find side length C, we're going to do the sine of 10 degrees over C equal to the sine of 90 degrees over 8. So we're going to cross multiply here, which will give us 8 sine of 10 equal to C sine of 90. Then I'm going to divide this sine of 90 on both sides. So then C is going to be equal to 8 sine of 10 over sine of 90. I just want to show you like when you were plugging this in your calculator. So the problem that we were looking at let me shorten this a little bit, is we need to input 8 sine 10 over sine 90. So you're going to do 8 times the sine of 10 divided by the sine of 90. And then you'll find out that your answer will be 1.38, whatever. In this case, we're still just rounding one decimal place, so we'll just call it 1.4. So we found out that side C is 1.4. Last but not least, let's look now for side B. And again, B, we're just doing the law of sines here. We're only use the law of cosines really just to find it the first time. So we'll do sine of 80 over B. It's equal to sine of 90 over 8. When I cross multiply, that'll give me B sine of 90 is equal to 8 sine of 80. You then want to divide both sides of these by the sine of 90. So then B will equal 8 sine of 80 over the sine of 90. And then what you're going to do at the end, you just plug that into your calculator and you'll find out that it'll be 7.9. And so our answer will be 7.9 for number 2. We got 2 down, 5 to go. So I'll try and finish this hopefully roughly around 7:30. So let's look at number 3. Now, again, we're starting here. We're going to label our triangle. We got A, B, C, A, B, C. Now, if you're a little confused on the difference between these two, capital letters will always be degrees, while lowercase will always be sine lengths. So notice, what do we have here? We have a complete set, so that means we're starting with the law of sine, but we're also given a side. The special case about the side length is that we could potentially have a second triangle where that second triangle could exist, and the second triangle shares the same original 3 pieces of information given, meaning that we will be given that 63 degrees, the 10, and the 8.9. Now, to see if the second triangle exists, what we have to do first is find out. Great question, Vivi. You are right on point with how do we find out if the second triangle exists. The way we find it out is we're going to do the law of sine to calculate the angle of the first original triangle. So looking at this red triangle, I need to find this angle, and we can find the angle by doing the sine of C over 8.9 equal to the sine of 63 degrees over 10. So again, keep doing what we've been doing so far. Cross multiply, we'll get 10 times the sine of C. It's equal to 8.9 times the sine of 63. And then we'll divide both sides by 10. So then that will give us sine of C is equal to 8.9 sine of 63 over 10. But here's the thing. In your calculator, what we actually need to do, don't divide by a sine. We're actually going to be taking the sine inverse of this value. So the 8.9 sine of 63 over 10. And again, just to recap, I'm only going to do this one time in our calculator, just how to input that value. We're going to do sine inverse is found by second sine, and then you just plug in everything that you see. So the 8.9 sine of 63 divided by 10 should look something like this, where everything fits within that sine inverse, and then you'll hit enter. Now, if there's an error, one thing you want to make sure that you're in degree mode. So I received an error here. Let's double check, make sure I did all my work right. It should work out. So let's see what error I did. Cross multiply. 8.9 sine of 63 10. 8.9 sine of 63 over 10. Sorry. This problem should work out. Let me see. I might have did something wrong. If I'll answer VV for side angle. Are we supposed to do the inverse every time to see if there's a second triangle? The inverse is really just to find the angle. If it gives you a domain error like it is right now, it usually means that there is not a triangle at all. So let me double check my math real quick and double check the problem, because this should be a 2 triangle or at least a 1 triangle situation. So 10, 8.9, sine 63 over 10, sine inverse of 8.9, sine 63 over 10. Oh, you know what? This is where let's try this. Entry, delete. So, oh, I see what happened. For the first one, I did an extra parentheses, hence the error. Yeah, Everett, good catch. Try it without the parentheses. Way to go. Good catch. Appreciate that. So without the parentheses, it should give us 52.46. But again, with degrees, we just round to the nearest whole number. So rather than 52.46, we're going to round it down to 52 degrees as a whole number. Good catch, Everett. So now we've got an angle of 52 degrees. To check, I know there's been all that mess up. We wasted about 5 minutes, but to check and see if a second triangle exists, what we're going to do is take these supplement. So we want to do 180 minus 52 and see what angle that would be. That angle would be 128 degrees. So we're essentially doing 180 minus this 52 to give us this new angle of 128. Now, with the new angle of 128, to check and see if a second triangle exists, we're going to add 128 plus 63. That total is going to be 191. 191 is greater than 180. That means no second triangle. If it was less, there would be a second triangle. And again, this only works in the case where you have a complete set and a side. So that means that there is no second triangle. And then all we have to do is finish the rest of this. And by finish the rest of this, we got to still complete and solve this final triangle. So we'll do 180 minus 63 minus 52. And we do 180 minus 63 minus 52. That gives us 65 degrees. And then looking at side B, the way we calculate for side B is we'll do the sine of 65 over B equal to the sine of 63 over 10. Cross multiply to get 10 sine of 65 equal to B sine of 63. And then we can divide both sides by the sine of 63. So then B would be equal to 10 sine 65 over sine of 63, which when simplified would give us, we go 10 sine 65 over sine 63, 10.17, or if we can just call it 10.2. So any questions on this double triangle problem before we move on? We got about 3 more to look at. We've mainly been working with the law of sine so far, or 4 more to look at. Sorry about that. So let's keep it going. So we got 4, 5, 6, and 7. So 4 more to look at. I'll try and pick it up just a little bit so I don't have too long of a podcast. And so looking at 4 here, we're going to, again, start out how we always do. with our triangles ABC. And so we're given sine length of A, sine length of B, and then the angle of A. So what do you again notice that we have? We're given a complete set and a sine length. That means there's a potential for a second triangle. So there is that second triangle could exist, and the reason that it could exist is because we are given a complete set, meaning the A couple. It doesn't have to be to an angle A and side A. It could have been angle A and or angle B and side B. So what we're going to do to first is we got to first make sure that this triangle really works for us. So we're going to look for angle B here. And when we're looking for angle B, we're going to do sine of B over 40. It's going to be equal to the sine of 30 over 10. Cross multiply, we'll get 10 sine of B equal to 40 sine of 30. And then we'll divide both sides by 10. That then will give us sine of B is equivalent to 40 sine of 30 over 10. And again, we're not just going to divide by sine, we're actually going to take the inverse sine of whatever that value is of the 40 sine 30 over 40. So rather than show you how to plug this in the calculator, I'm just going to go it quickly in my calculator. Or let's show you. Let's just see what happens. So we're going to take the sine inverse of 40 sine 30 over 40. So it should look something like this. This is for our original triangle, and we find out that it is, oh, you know what? That shouldn't have been a 40. That should have been a 10. I copied that down wrong. That should be a 10. Again, mistakes that you make when you go too fast for yourself. So let's bring that equation back. And so then rather than it being 40, it should be 10. And boom, domain error. Value entered is not allowed or in the command function. Example. So when you get this, yes, it's good to question yourself like I did that first time when it was two triangles. But if you find out where you plugged it into the calculator, right, and everything worked out, and there was a domain error, it is a no triangle answer. So this means our answer is no triangle. Now here's the thing. If there's no first triangle, there can't be a second triangle. So there's no triangle at all, and so our answer in this case will just be no triangle. All right, moving on. Now we're at number 5. Looking at number 5, we're starting out how we always do, with writing out our angles and writing out our side lengths. Again, capital letters are angles, side lengths are lowercase, and so we have side length 16 for A, side length 18 for B, and degrees is going to be 60. So what are we given here? A complete set and a side length. That being said, we're going to see, hey, maybe this one is going to be our second triangle, because one was only one triangle, one was no triangle. We'll see if this one is our second triangle. And so again, what we're going to do right here is find that angle, and we're going to find that angle by doing the sine of B over 18 equal to the sine of 60 over 16. And so, oops. Okay, still working. Good. All right, and so to solve for sine of B, we're going to cross multiply to get 16 sine of B equal to 18 sine of 60. We'll divide both sides by 16 here. And that'll tell me sine of B will be equal to 18 sine of 60 over 16. So b will then be equal to the inverse sine of 18 sine of 60 over 16. When we calculate for that, we will get 18 sine 60 over 16, 76.9. But again, for 76.9, we don't really want decimals for angles. We're going to just take the whole number of 77 degrees. And so what we're going to do is take that 77 and subtract it from 180. So 180 minus 77 is going to give us 103. Now to check and see if this triangle is going to work, we're going to do 103 plus 60. And this is going to be 163. 163 is less than 180. So that means there is a second triangle. And so that being said, what we have to do is solve for everything now. I'm going to delete that just so I have a little bit more space to write. So I'm going to focus first solving on my first triangle, just because that's what I just want to spend a little bit more time on. I'm going to do 180 minus 60 minus 77. And that will give me 43 degrees. And then I'm going to take a look at, looking for a side length C here. And then C can be found by doing the sine of 43 degrees over C equal to, I'm going to just use the first one, sine of 60 over 16. We'll cross multiply to get 16. Sine of 43 is equal to C sine of 60. Divide both sides by the sine of 60. And so then C will be equal to the 16 times the sine of 43 over the sine of 60, which eventually simplifies to 12.6. And so we've solved the first triangle, but now we got to really focus on solving the second triangle. Sometimes it's just helpful to just notice if there is a first triangle or a second triangle, and that could be a potential question, is just notifying, like on the homework, hey, do two triangles exist? And you could just say yes and then be done. Or if it says like maybe justify your answer, justifying your answer is kind of doing what I am right now by proving, hey, this is my two triangles and showing why they exist and stuff like that. And so that was kind of a tangent. Let's finish on finishing this triangle. We found 17 degrees by just doing 180 minus 103. I'm going to divide these two just so that we know that they're two different triangles. And so then the find side C, I'm going to do sine of 17 over C equal to the sine of 60 over 16. Cross multiply to get 16 sine of 17 equal to C sine of 60. We'll then divide both sides by the sine of 60. And so C will be 16 sine of 17 over sine of 60, which will give us 5.4, I think. Yep, 5.4. And so, yes, this takes a little bit more time to solve, but we did solve it nonetheless, and we got through it together, which is fantastic. And again, if you have questions as we're going, please just let me know, and we'll keep it going. Appreciate the 4 people that are viewing right now. Let's keep it going. So we got 2 more law of sine questions. So, hey, I know earlier I said join us at 7:30 to work on vectors. We'll probably get on vectors in about 8 minutes once we knock out these 2 problems. Now, we've done a lot with law of sines. I think this one's going to focus on law of cosine. And so with the law of cosine here, it starts just like any other triangle with finding out your angles, labeling those angles, finding out your sides, and labeling those sides. So we got, notice that there is no complete set. And when I say complete set, that's an angle A and side A paired together, or B or C. And so this will be using the law of cosine. So what we have to do first is, if you're given at two sides an angle, you first have to find that third side, because we need to make a complete set. And so to make this complete set, we're going to take side B here. And when we do the side B, that will be essentially B squared is equal to 7 squared plus 3 squared minus 2 times 7 times 3 times the cosine of 90 degrees. When we do that, essentially that will give us 7 squared plus 3 squared, gives 58, minus 2 times 7 times 3 times the cosine of 90, which is 0. So we'll just take the, so b squared is really just 58, and we can square root both sides to get b equal to 7.6. Now, you could have just done this in your calculator and still gotten the right answer, and you'd be fine. The main thing to remember for this is, for law of cosines, there are no double triangle potentials. It's always going to be one triangle every time. And so now if we're using the law of cosine, you got to start with the smallest side first. So this is going to be the first. So step 1, you want to work here. Step 2, go to find angle C, and then step 3, find angle A. And that's for all triangles that you're given 2 sides and an angle. Now, to find sine of C, we're just going to do the sine of C over 3 equal to the sine of 90 over 7.6. We'll cross multiply to get sine of C, or 7.6. Sine of C is equal to 3 sine 90. And so then that will be divide both sides by 7.6. So we'll get sine of C equal to 3 sine of 90 over 7.6. And so we're going to take the inverse sine of that to get of 3 sine 90 over 7.6. When we take the inverse sine, we'll find out that angle C is like 23.18 degrees. But again, we're rounding to the nearest whole number for this, and that'll be 23 degrees. Now let's go to the last problem for today. The last problem for today is going to be, not last problem for the day, but the last one for this problem is going to be angle A. And all you got to do for angle A is just do 180 minus 90 minus 23, which is just going to give us a nice even number, or odd number really, of 67. All right, we're now moving on to the last problem of law of sine. So that's going to be number 7. And so let's go number 7. Let's finish it out for the law of sine, law of cosine. I'm kind of craving vectors. And so with that being said, we're going to go on to angles A, B, and C, sides A, B, and C. And so angles, we're not given any, but we are given some sides. We're given side A, B, and C of 4, 6, and 9. The order that we want to start this is always starting with the smallest side and then working your way to the largest. So to find, what we got to do is first find angle A, because that is across from the shortest side. So what we're going to do is A squared, which in this case will be 4 squared, is equal to 6 squared plus 9 squared minus 2 times 6 times 9 times the cosine of A. Now, this one you kind of do want to break it down step by step because there's room for error. And so this will give us 16 is equal to 117 minus 108. Do not subtract these two. You want to, or sorry, do not subtract these two. Do not subtract 117 and 108 because 108 is being multiplied by an unknown variable, which is the cosine of A. So what we'll actually do is subtract both sides by 117, which will give us negative 101 equal to negative 108. And then we can divide both sides by negative 108, which will then give us 101 over 108 will be equal to cosine of A. So to find A, we really need to take the inverse cosine of that fraction. And then when we do that, we'll find out A is going to be equal to 20.74. But we really don't want rounded numbers for angles. I just like a nice even number of 21 degrees. So that's how you find for the first one. Now for angle B, what we're going to do is we're going to look at finding this through the law of sine. And so we're going to do sine of B over 6 equal to the sine of 21 over 4. And so we'll cross multiply to get the sine of, well, 4 times the sine of B equal to 6 times the sine of 21. We'll divide that 4 out of here, get the sine of B equal to 6 sine of 21 over 4, and then take the inverse sine of that. Essentially, to find angles, where if you're looking for an angle and it's like the first one that you work on, it's normally going to be using the inverse sine or cosine. So if it's a law of cosine problem, use the law of cosine. If it's a law of sine, use the law of sine. And that will be roughly 32.52. But again, we'll round that to 33 degrees. And then to find this last angle, we're just going to do 180 minus 21 minus 33 to give us 126. All right, so for the people that are watching, are there any questions on law of sine and law of cosine before we move on to the vectors? And you can respond on the comments. That way I know, because I know you can't really talk to me. I'm going to go, I'll send a remind out right now that we're starting the vector in case anyone was looking. Yeah, Vivi, I see your question. Can you clarify how you find a second triangle again? I'll do that once I send this message out. Oops. Hang on. A little issue with my remind on my phone. All right, so second triangle. There were 3 examples that we looked at. One of them was the case of one triangle. One of them was a case of no triangle, and one of them was a case of 2 triangles. Again, the only time that we can have the second triangle is if you're given a complete set and a side. Now, I know in all 3 of these, it's like given the set A, but if you were given angle A or angle B and side B, or given angle C and side C plus a side, it would work out all 3 times. It's just a matter of fact that we are actually given angle A and side A for all 3 problems. For the first case, what we have to do, we were given the numbers in red, and so we had to find the 52 degrees here. Now, we found 52 degrees by doing the law of sine. And after we did the law of sine, we got the 52 degrees. To check and see for the second triangle if it exists, we will always do 180 minus 52 degrees because sine, just to kind of recap on sine inverse is limited to 90 degrees. It'll never give you an obtuse angle. And so because of that, we have to check and see if there was an angle greater than that. Because if I had sine where the height was 1/2, it could also be 1/2 here. It's in two locations. And so we check and see if it exists by doing 180 minus 52. In this case, it was 128. If it is greater than 180, which it was in this case, like right here, it was greater than 180, there is no second triangle. And so, that's just kind of the process of checking. For the second one here, we got a no triangle. And so for the no triangle, we got that because we had an error, domain error. And with the domain error, we that just means no triangle. And since there's no triangle for the first one, can't be for the second. And then the last one here, we were given the angles and sides in blue. And so we found the red angle of 77 by using the law of sine. And so I did 180 minus 77, which gave me 103 degrees. When I combine that with my original angle of that 60 degrees, I see that I get 163, which is less than 180. And because it's less than 180, second triangle exists, and then we have to solve and completely solve the triangle. Any questions from there, VV, before we move on to vectors, or anyone else? Good. No problem, VV. Thank you for asking. Appreciate it. All right. Now let's move on to vectors. Again, if you're just now joining us, we're about to start vectors. And first off, on the podcast that will be posted on the my GAC, you can skip around. So this is the, I don't know how long we are in this. So we're 45 minutes in, roughly 43 minutes. So about 45 minutes will be the, let me write a note of that. So we're at 43-minute mark is vectors. Oh, wow. We've been here a while. I've been here a while. Y'all have been here a while. Thanks for checking in. So let's get to it. Now we're sketching each vector as a position vector and finding the magnitude. Given this information, I know on the review guide that's posted on my GAC that there was no graph like this. So I'm providing one right here just to kind of show you what it means to sketch. On these two axes, we know this is the x-axis. And we're actually going to turn this into the y-axis and the j-axis, where I is essentially the unit vector that is going in the x direction, j is the unit vector going in the y direction or the vertical direction. When sketching the vector, what this means that if I'm looking at -6 here, I'm going left 1, 2, 3, 4, 5, 6, and then that 2 means I'm going down 2. For vectors, I'm not just drawing a point. A vector starts at the origin and goes all the way to the point of -6i to j. Make sure for vectors that you include an arrow because vectors have magnitude and direction. And so we want to make sure that we have that direction with us. And so with that, we sketched it. Now to find the magnitude. The equation for the magnitude is the square root of a squared plus b squared. That looks very similar to our Pythagorean theorem, which is a squared plus b squared is equal to c squared. And so it's just if I square rooted both sides, I would find out that c is equal to the square root of a squared plus b squared. And so the it's just find the hypotenuse really. And so what we're going to calculate the magnitude, we will do the square root of -6 squared plus -2 squared. I do want to show you on your calculator some things that I notice that happens when people do this. When you're on your calculator and you're doing the square root of -6 squared, make sure that -6 is on the inside of the parentheses and that square is on the outside of the parentheses. Same thing for -2, because we should get like 6 point blah, blah, blah. Like that's a little complicated because your calculator won't give the exact answer. I want the exact answer. That will be specified on the test. If it's rounded, you get the 6.3. But because I want it to be exact, let's kind of go take the -6 squared, which will be 36. -2 squared should be 4. That will be square root of 40. And again, you could check this by doing the problem without the square root, meaning that you could have done -6 squared plus -2 squared to find out that you get 40. It's just two different ways of doing it. All right, let's go to the next one. We are sketching the vector as a position vector. If I'm going too fast on these, let me know. I'm just going fast because these are the easier of all the problems. And so again, just a reminder, this represents your J line. This is your I line. And so this 5i, 2j for vector means I'm going over 1, 2, 3, 4, 5, and then up and then down 2. Vectors again are starting at the origin and going all the way and stopping. You do not go past this. If you go past this, that means you did not graph or sketch the vector correctly, because this is the specific length of our vector. And so what we're going to do is use that formula of a squared plus b squared, and we'll get the square root of 5 squared plus -2 squared, which will give us 25 plus 4, which is square root of 29. So that is for sketching the vector and finding the magnitude. Now let's talk about giving an initial and terminal point. Now visually what this means, we're just graphing, we're just trying to write out the vector. The formula that you can use this is if your initial point is the point of x sub 1, y sub 1, and your terminal point is the point of x sub 2, y sub 2. Your equation would then be x sub 2 minus x sub 1, I, plus y sub 2 minus y sub 1, j. Now that's a lot of numbers and letters and stuff. Basically, for terminal points and initial points, so to graph it in turn or to write the vector in terms of I and j, you're just going to do the terminal minus the initial for x, so 4 minus 4, and then you'll do the terminal minus the initial for y, which will be 3 minus 5, j. So we'll get 4 minus 4, which will be 0i, 3 minus 5, which will be -2j. Well, 0 to not that's a -5. So I went a little ahead of myself. That should be 3 minus -5j. There's a 0i. So then that would give us a plus 8j. This 0i doesn't really exist, so the final answer would be 8j. I'm fine with this 0i plus 8j up here, but I would prefer the 8j. Let's take a look at the next one, number 11. Given the initial and terminal point of a vector, write the vector in terms of I and j. Again, we're going to use the formula that we used from before here. So what I'm going to do, I'm just going to do a nice little copy paste just so that I can have it on the next one. Let's copy, paste, boom. All right, so let's solve it. We're going to take the terminal point of -6 and subtract that by the terminal point of 2. And then we're going to take the terminal point of 6, subtract that from -5 for our j vector. So then this will give us negative 8i plus 11j. Bada bing, bada boom. Any questions on 8, 9, 10, or 11? All right, let's get it going then. Now we need to write the vector in terms of I and j. Again, you notice a trend here. We're just writing the vector in terms of I and j given different scenarios. In the case of vectors in terms of I and j, this process essentially comes from SOHCAHTOA, where if I was giving you an angle and the hypotenuse, you would be able to find out the side length of j and the side length of I using your sine and cosine. And so what we do is we use the magnitude, because magnitude is essentially the length, times the cosine of your angle given. Oops, I'm just doing the standard formula. Cosine times the magnitude times the sine of your angle, j. And so to solve this, we're just going to do 12 times the cosine of 225i plus 12 times the cosine of 225j. Again, you're just going to plug these in your calculator, and I don't need a rounded answer, or an exact answer. Just give me the rounded answer of 1 decimal place. So that should have been negative 8.5i, and oops, that should say sine, not cosine. Sine. And then actually it works out where it'll be negative 8.5j as well. The reason that is because it's a 45-degree angle or it's a reference angle for 45 degrees where they would be the same. That won't always happen, but like for number 13, we'll see. So again, the formula is, I can copy and paste. For the formula here, we're just going to copy this stuff, paste the formula. And so to solve it here, we're going to do 1/2 times the cosine of 113i, and then add that to the 1/2 of sine of 113j. That's going to give us then negative 0.2i and 0.5j. And again, we don't need to worry about exact numbers. I'm fine with rounded answers. And so, any questions on how we found those? All right. Now I have a couple of vector operation problems for us to look at. For these vector operations, essentially you have vector u, vector v, and vector w. All these essentially are given to us. These aren't not the standard, so vector u isn't always I minus 2j. I'm just assigning values. And so what we're going to look at is essentially doing vector operations for this. Essentially, wherever you see a u, you're going to plug in I minus 2j. Wherever you see a v, you'll plug in negative 4i minus 3j. And then wherever you see a w, you're going to plug in 3i minus 5j. So basically, once you've plugged in all of those values, you then will add your i's, add your j's, and you're done. And so let's kind of look at this. So we're going to have the parentheses of 2. Now this is going to be multiplied by I minus 2j, which is then added to vector v, which is negative 4i minus 3j. That is then subtracted by w, which is 3i minus 5j. This looks like essentially an algebra problem. And so to solve this, what we're going to do is distribute the 2 to each value here to get 2I minus 4j. Then we're going to simplify this. This is essentially a plus 1. And so you would distribute that plus 1 to both of those, which is essentially just negative 4I minus 3j. And then finally, you have a negative 1 here, which when distributed will give us a negative 3I plus a 5j. From there, we're just going to simplify everything by adding all of the i's together and all the j's together. So that being said, we have a 2i minus 4j minus 3i, or sorry, 2i minus 4i minus 3i, which will give us, let's just do it this way, 2i minus 4i is negative 2i, minus 3i is negative 5i. And then if you look at the j's, negative 4j minus 3j plus 5, negative 4j minus 3j is negative 7j. And then when we add 5j, that will be negative 2j. So essentially combine I together and your j together. When you do that, these aren't on the study guide. Will they be on the test? Yes, they are on the study guide. On Friday, I asked y'all to copy down those problems onto your study guide in class. But they are also available on the study guide on my GAC. But great question to ask, Everett. Appreciate it. But yes, they will be on the test. So make sure to take a look at these. And again, ask questions as we're going. So for number 15 here, what we're going to do is identify, we're just going to keep the same for all these operations. Wherever you see a U, plug in U. Wherever you see a W, plug in W. And so what we have here is a negative U. So U is the I minus, I don't need that parentheses. I minus 2j, and then we're adding it to 3I minus 5j. And so what we want to do first is simplify the inside and then distribute the negative 1. So when we simplify the inside, that's going to be combine your i's. So here's your i's. Like beforehand, we have our i's here, and you have your j's here. Here you have your i's, combine your i's, combine your j's. So I plus 3i is 4i, and then negative 2i minus 5, or negative 2j minus 5j is negative 7j. From there, this is essentially a negative 1, which will be distributed to the 4i and the 7j to give us a final answer of negative 4i plus 5j plus 7j. These are essentially operations on vectors. And so now we got let u equal, or actually this isn't going to involve u. We're looking at the w vector and the v vector. So what we're doing is we're taking the value of 2 here and multiplying it by our w vector. And so our w vector is 3i minus 5j. And we're going to subtract that by 3 times our v vector, which will be negative 4i minus 3j. And then let's get some distributing going. So we're going to distribute the 2 to each of these to get 6i minus 5, or not 5, that should be a 10. 6i minus 10j. And then we're going to distribute the negative 3 to each of these, and that should give us a positive 12i plus 9j. From there, combine your i's to give us 18i. And then combine your j's to give us negative 1j, which in this case I can just write as a negative. J. All right. So before we move into the nitty-gritty word problems, any questions on vector addition? All right, if that's the case, let's get it going. I'm going to just do a little check on how, so I can write like a little time marker. We've been at it for an hour, so 43 minutes is the vector mark. 1 hour is the, 1 hour and 1 minute will be the word problem mark. Or a minute and 2. We'll do be safe, minute and 2. And so we got 3 word problems to look at, 1 simple and then 2 that are slightly complicated, but all involving planes. This is a good hint on what type of word problem we're going to be looking at tomorrow for the test. Doesn't mean that the forces won't be on there, but you definitely going to want to know your planes for sure. So the wind is blowing at miles per hour in the direction of 30 degrees west of north. So when we're looking at word problems, we always want to draw a picture. So if I have here, the wind's blowing 20 miles per hour, well, let's look at the direction, west of north. Never eat soggy waffles. And so we're going 30 degrees west of north. This angle here is 30 degrees. We know that the magnitude is 20 miles per hour, which tells me that the length of this vector is 20. Let's calculate it. Now, to calculate it, we are using our formula of absolute value of cosine of all. We're using that formula again. But then the issue is we aren't going to be using the angle of 30 degrees because when we use sine and cosine, it's always based off of this angle here. It's always in between the x-axis and the terminal side. So we won't use 30. So we have our magnitude, which is 20. We thought our angle would be 30 degrees, but it's actually not going to be 30. It's going to be whatever 30 minus, or 90 minus 30 is, which in this case is 60. And so we're going to use 60 degrees. So that means we'll do 20 times the cosine of 60i plus 20 times the sine of 60j. When we do that, we will find out that our cosine will be a negative 10i, and then our sine will be a 17.3j. 1 decimal place is fine for that. And so this is just kind of writing a vector given the wind blowing. So that's just writing the vector. We do operations within that, but this is just step 1 of writing the vector. Now let's get to the word problems. So word problems, I know these are our favorite, but essentially here's the thing. First off, we got to see what we have. We have a plane that's flying at a speed of 5. I'm not going to read the problem. You can read it, and you've read it before if you've done the thing. In this case, for not the bearing, the bearing would be nice to have. So don't worry about the not the bearing part. I would like the bearing. And so step 1, oh gosh, mainly let's look here and just try and figure out what are we looking for. We're trying to find the wind. We know that if you take a plane speed and add it to the wind speed, you'll essentially get the ground speed. So in order to find the wind, we'll take the wind and just take the ground speed and subtract that from the plane speed. If you're solving for the ground speed, this would be a different story. So why does the angle, oh, sorry, I missed this earlier, Vivi. Why does the angle give and touch the y-axis and not the x? This is a recap from before, Vivi. The reason it's touching the y-axis and not the x is based off information here, west of north. So what it means to be west of north is that north is the main direction that you're going. So north is the main direction. West is where you're coming from. So I'm going north mainly and then west. And so that's where that angle is coming from. So west of north is going north and then west. It's a little confusing in that, but that's kind of the main reason on why it's in between the y-axis and not the x. If it was the other way, if it was north of west, then we would have it where it's above the axis there. And so let's kind of go back to the word problem. So what we need to do is we kind of found the wind vector. So wind is going to be our ground speed minus our plane speed. So essentially 5 steps what we're looking at. Step 1, we want to find the wind speed. Step 2, we want to, well, we don't want to find the wind speed. Sorry, we can't find the wind speed. That's like the last step. Step 1, we want to find the ground speed. Step 2, we'll want to find the plane speed. Step 3, we'll look at finding the wind, which is our resultant vector. And step 4, we'll look for the magnitude. And then step 5, we'll find the direction. And so step 1, looking for the ground speed. For the ground speed, we're going to look, ground speed is 500 miles an hour, 44 degrees east of south. So that means if I'm here, I'm going 44. If this is south, going east of that, that tells me this is 44 degrees east of south. If you find plane speed first, that's okay. Yeah, you're good. The order doesn't matter. I just found the ground speed so that when I subtract, I won't be as confused, but finding the plane speed first is okay. So we got 49 degrees here. We are going to then find this angle, which is 90 minus 44, and that will give me 46 degrees. So our ground speed vector is going to be 46, or not 46, sorry. It'll be 500 times the cosine of 46 degrees I plus 500 times the 40 times the sine of 46j. That then, cosine of 46, that's going to give us 347.3i plus 35967j. Now, here's the thing. We can't have these as pluses. Does anyone know why? They can't be pluses because in quadrant 4, you have a positive cosine and a negative sine. So rather than adding, it's actually subtracting. And so our vector for our ground speed is good. And now let's find our vector for our plane speed. So if I'm looking for the plane here, we're going to first draw it out. So I got 540 miles at a bearing of east to south. Same thing, east to south, going 36 degrees. Can't use 36. So we're going to do 90 minus 36. And when we do 90 minus 36, that'll give us 54 degrees. And so we'll do actually the 54, not 54. We'll do 540 cosine of 54I minus 540 sine of 54j. When you calculate that, again, it's minus again because in quadrant 4 we have a positive then a negative value. So that'll be 540 cosine of 54 will give us 317.4i. And then we'll have 540 sine of 54 will give us 436.9j. Now, two's done. Now let's find the resultant vector. To find the resultant, we're going to take the ground speed vector, which is 347.3i minus 359.67j. And we're going to subtract that from the p vector. Now, let's do it this way. When you subtract the vectors, so we're doing the ground speed minus the plane speed, 317.41i. When you're subtracting, make sure you distribute that -1. So then the wind vector would be 347.3i minus 359.67j minus 317.4i plus 436.9j. So then we'll get 347.3i minus 317.4j, or 317.4i. So then that will give us 29.9 for our I vector. And then for the J vector, we'll do 359.6. We'll just call that 0.7 plus 436.9 to get oh, oops, that's what I did. I didn't do this subtraction, my bad. 77.2j. And then that is our wind vector. So now we're going to find, so this is going to be the key for us. This part, we need to find the magnitude and direction for. Again, for the magnitude is found by doing the a squared plus b squared. So all you're going to do is 29.9 squared plus 77.2 squared. Take the square root of that. I am fine with the non-exact answer for this. So that'll just be 29.9 squared plus 77.2 squared to give us 82.8, or we'll do 82.78 for our magnitude. So that's to the nearest miles per hour. And then for the direction, which is the last thing that we gotta look for, is going to look like this. Direction is drawing this vector. So if I draw this vector, we'll have it where it's in quadrant 1 because both are positive. So it's like 77.2 and 29.9. And this is my vector here. So if that's my vector, essentially what I'm trying to do is find that angle. And to find that angle, I can use my tangent inverse. So tangent inverse of 29.9 over 77.2 will give me my direction or my angle. And again, I want it in a bearing format. So then that'll be tangent inverse of 29.9 over 77.2, which is 21.1 degrees. Oops, I messed that up. I wrote these down wrong. I don't have people call me out right now. And the reason I know I messed them up, 29.9 is your I vector. And so 29.9 should be the X, not the Y. So it should have been 29.9 here. And then 77.2 there. So then the angle would have been the tangent inverse of 77.2 over 29.9. And so when we do that, we'll get 68.8 degrees. Which is essentially 69 degrees north of east. Why is it in the first quadrant? It's in the first quadrant because you have a positive here and a positive there. And so because of those two positives, we know we're kind of basing off our vector from our I value and our J value. So since I is positive and J is positive, where on the coordinate plane is I and J both positive, or where X and Y are both positive? And that is in quadrant 1. Any more questions before I move on to the last problem? I'm going to get a sip of water real quick. All right. Here we go. Last problem of the day. It's actually very important to know how to do this one as well. And so I'm going to kind of copy our little 5-step thing that we covered earlier here. Okay. Let's get that there. Bam. Worked. Yes, worked. All right. So the only difference in this problem is that we have to read what we're looking for. So if a plane is flying at an airspeed of 400 miles an hour, heading 204 degrees, a wind 40 miles per hour is blowing from east to west. From east, that means it's going west. So we want to find the ground speed and direction of it. If we're looking for the ground speed, that means our problem is going to be wind plus the plane will give us the ground speed. So this is a addition problem. On the test will be an additional problem. And so we want to find the, let's look at the wind. Whoa, I want a different color. Wind. All right, so what we need to do is first find the wind. Now, if you find the plane first, like whatever it did, that's completely fine to do. And so to find the wind, in fact, I'm going to try and give myself a little bit more space this time. So to find the wind vector, what we're going to do is draw it out. And our wind vector is going from the east. That means if it's going from the east, it's going to the west. And so because it's going to the west, I need to think about how many degrees is that. This, if it's going to the west, that's known as 180 degrees. And so when we write down our problem, I have the magnitude here. And so that would be 45 times the cosine of 180 degrees I plus 45 times the sine of 180 degrees J. Well, 45 cosine of 180 will give me negative 45I. And then this will actually be 0J. So then for vector W, it'll just be negative 45I, and we're done. Now, let's look at vector P. P stands for plane. If we're looking for our vector P, this is going to be found by looking at our information. So we got 400 degrees or 400 miles per hour at a heading of 204 degrees. That's in quadrant 3 here. So in quadrant 3, we're at 204. If you're given a problem where it's telling us what you need to input, like if it's the whole 204, you don't need to do the figure out, okay, does what needs to be positive, what needs to be negative, only if it's in the east of north or north of east, or whatever, if it's east of something, west of something, north of something, south of something. Those are the only cases where you need to change the values of your cosine and sine, or your I and your j. So in this case, we're just going to do 400 cosine of 204i plus 400 sine of 204j. And so then that's going to give us 400 times the cosine of 204 will give us negative 365.4i. And then we'll add that to 400 sine of 204. But since it gives us a negative number, we won't add that. We'll actually subtract 162.7j. And so to find out what's going to happen, we're going to do our vector w plus vector p. So then that would be the vector of negative 45i plus negative 365i minus 162.7j. If there is no j, when you do the 0 plus negative 162, you're just going to get negative 162 again. But when you add 45, or do negative 45 plus negative 365, you'll get negative 410. Well, that should be 65.4. So 410.4 I minus 162.7j. And so now we got to find our magnitude. Magnitude, we're going to do that a squared plus b squared. So that's just going to be found by doing the square root of negative 410.4 squared plus negative 162.7 squared. And when we do that, I just want the exact answer. Should give us 441.47 miles per hour. All right, that's my ESPN app. Just giving me an update on the dogs and how they are destroying it this year. And looking forward to having a little easy week this week. I digress. Let's get back. Sorry. And last thing that we need to find is direction. And so for the direction, essentially what we're doing is drawing the coordinate plane. Here we have a negative and a negative. That's going to be in quadrant 3. And so in quadrant 3, if that's my vector, I'm essentially going over 410.4 and then going down negative 162.7. And so to calculate the direction of this vector, again, I'm looking for this angle here. I'm going to use tangent because tangent is opposite over adjacent. And so the angle will be the tangent inverse of negative 162.7 over negative 410.4. And that's going to give me where our angle will be angle 162.7 over 1. It will give me 21.62 degrees, but we'll just round that to 22 degrees. And the way that we describe it is 20 degrees south of west. And that's our answer. All right. Well, hey, appreciate y'all sticking it with me to the end. If y'all are just joining us or anything like that, I'll take any more questions before we head on, or before I head on out of here. So any questions? My internet's buffering. I see Y in the first quadrant. I think we covered that. Any questions? All right. Well, I'm not seeing any questions. I see that 5 of you are watching this or just kind of looking at it. Don't know what it is, but appreciate it. I'm going to stop the podcast now. Hopefully, y'all have a good night rest. I'll be here tomorrow morning at 7:30, Lord permitting. Y'all have a great day and go Dogs.